Hello, this is Mr. Collier, and today we're going to be looking at Venn diagrams and answering problems with Venn diagrams. So our Venn diagrams are going to include a rectangle to represent the universal set, and then subsets are going to be represented with circles inside the rectangle. So in this example, we got the universal set is x such that x is less than or equal to 10, and x is an integer. I don't think that should be a negative symbol there. It should be just integer. Okay. And we have s. That's supposed to be positive. Sorry. That should be positive. So we're looking at the positive integers. Alright. So that's 1, 2. That's the numbers 1 through 10. So s are these numbers, and the set t contains these 4 numbers, and then we can see here that on the intersection of s and t we have 1 and 2, because 1 and 2 are in both s and t. Numbers 7, 8, 9 are outside the circles because they're in a universal set but are not in s or t. Okay, so let's look at these shaded examples here. The first example is an example of a subset, or we can write B is a subset of A, right? Or we can say B is a proper subset of A as well. All right, so that's what a subset looks like. And here is the intersection of A and B. So that's the intersection of A and B. And the next one, well, we can write this in a few different ways. But one thing we have here is we have, actually it's a bit of a bad diagram. Forget about these little bits right here. Basically what we have here is everything that's in A. So I guess I would just say A here. And next one we have disjoint sets. Maybe I can represent this as A intersect B equals the empty set. There's nothing. They're disjoint sets, so there's nothing in between them here. Alright. Now we're going to do the shading for these. A intersect B is everything that's shared in common here. A intersect the complement of B. So the complement of B, that means everything that's not in B. And well, one thing you can think about intersect is they have to be in A and not in B. So everything that's in A and not in B would be this amount. Okay, this is everything in A and not in B. Here we have everything that's not in A, not in B, and we can think of this as or. So not in A or in B. So that's actually going to include some parts of the universal set. Let me just shade everything that's not in A first. Okay, everything is not in A. So if this first circle is A, I'm going to shade everything that's not in A. Alright, so this is everything that's not in A. Or it's in B. So if that second circle is B, then I have to also shade this amount. So this is everything that's not in A, or it's in B, and that's everything that we shade here. Okay, so I'm going to do the same thing for the next one here. I'm going to shade everything that, well, let's shade everything in A first. So it's A or not B. So everything in A is going to be the entire circle, or not in B. So I need to shade everything now that's not in B. So all this stuff here in the universal set is not in B. Okay, let's look at another one now. So this is the complement of A intersect B. Alright, so let me just shade that in green here. Let me shade the intersection of A and B. There's the intersection of A and B. So we want to shade everything that's not in the intersection of A and B. So that's everything else. Okay, so everything else. Alright, so now I'll just erase that green bit here. Okay, so this is everything that's not in the intersection of A and B. Okay, so next I'm going to do the same method. I guess I'll do the union of A and B is everything that's in A or it's in B, so I shade the entire two circles, right? So the complement of that is everything else that I didn't just shade. So everything in the universal set that is not in A or not in B. And then I'll just erase this green bit again. Okay, some more examples. Okay, so let's take a look at this one. Let's label this U, and this is A and B. And we're going to draw a Venn diagram to represent A intersect not B. So the intersection of A and not B. So let me first of all shade not B. Let's try that. So I'm going to shade not B. So everything that's not B is everything that's not in that little circle there. Okay, and intersect with A, that means this part right here. Okay, so that's everything that's in A and not in B is that part right there. So there. So that is A intersect not B. Alright, so now I'm going to answer the questions on the bottom here. Find complement of A. So the universal set are the numbers from 1 to 11. So the complement of A is, now maybe I can probably do that a bit better with putting the numbers in here. Or I can just look at the set, I suppose. Okay, everything that's not in A is 1, 2, 7, 8, 9, 10, 11. A intersect B. So we have 3, and 5 are in both of those, so you can even put it in the diagram. 3 and 5 are in the intersection here. And the last one, A union B. So that's things that are in A or B. So you just need to list all the elements in there. 2, 3. So we have 2, 3, 4, 5, 6, 7, 9. 2, 3, 4, 5, 6, 7, 9. Okay, so that's that. Okay, given the sets below, find each expression. Alright. So everything that's not in A. So X is all the even numbers now. So this universal set, first of all, that means the numbers 1 to 10. Basically the number is 1 to 10. The integer is 1 to 10. Okay, so everything that's not in A is the even numbers from 1 to 10. So not A, or complement of A, are the odd numbers. So 1, 3, 5, 7, 9 is not in A. A intersect B. Now it might be helpful to use a Venn diagram here. Okay, so I accept this Venn diagram and I'm going to put in some numbers here. Actually, let me put this in here. A, B, C. And in A we have the even numbers. Okay, so we have A intersect B, so everything that's in A and B. So B, let's write out what B is here actually. B is the integers from 5 to 8, so 5, 6, 7, 8. A is the integers 2, 4, 6, 8, 10. Okay, A intersect B are the numbers that are in both, so 6 and 8. Okay, A intersect B, the complement of that. Alright, so if I want to do that, I can look at A and B Oh, there's a, well, we already have the intersection over here. So everything that's not in that would be 1, 2, 3, 4, 5, 7, 9, 10. Okay, B union C, we need to just list all the elements in B and C. So B we have 5, 6, 7, 8, and C we have 3, 6, 9. So I'm going to do 3, 5, 6, 7, 8 are all the elements of B, and then 9 we have in C. Okay, C intersect the complement of A. So C is 3, 6, 9. Okay, and we need to see if we have 3, 6, 9 in the complement of A. 3, 6, 9, we have 3 and 9, so it's just 3, 9. And now we have C intersect complement of A union with B. So we got the C intersect complement of A over here, right? So we know the set's going to have 3 and 9 in it. Let me just write it out of order now. 3 and 9 in it from this part. And then we have to add together the elements from set B, right? So 5, 6, 7, 8. So that's 5, 6, 7, and 8. It contains all these elements. So now I'm going to rewrite in order. 3, 5, 6, 7, 8, 9. Okay? You might notice too that these are actually equal to each other too, right? So that's something interesting to note. Alright, describe each of the following in words and draw a Venn diagram to represent the situation. So the first one we have, B is a subset of A, and I can draw that by drawing A, and then B is totally inside of A. Okay, A intersect B is 0, so I can do that like this. A, B, they don't intersect at all, so that's what the Venn diagram looks like for that one. Okay, shade the following regions of this Venn diagram. So P intersect Q. I'm going to shade that blue. So this is P intersect Q in blue. Q union R. So that's everything in Q and R. So I'm going to shade all that green. Not P. So not P is basically everything not in P. So that includes these bits of the other circles there. And then we have not P intersect Q. Alright, so not P intersect Q. So we have not P is already shaded in red. So the intersection of not P and Q is going to be the section of Q that is red, right? Alright, and the last one, we have, okay, we already have this region done in black, right? So now union of not R. So everything that's not in R and everything that's not in R, I'm going to shade black as well. So the last region is going to be the entire thing that's not in R. So I'm going to shade it all black here. Okay, so it looks like all this, except for this region here. Okay, next, it's given that E is all students at a school, so I think in this case E stands for a universal set, right? Shade the following regions, give a brief description of what they represent. So A intersect B, students, okay, so A intersect B is here. This represents students who enjoy films and math. Alright, so next one. A union C. So everything in A and C that's not in B. Everything in A and C that's not in B. So A and C. I'll shade all the parts of A and C that are not in B, and there we go. Alright, so what does that represent? Well, they're in A and B, or A and C, so they enjoy films, they enjoy basketball, they don't like math. So these are students who enjoy film, basketball, but not math. Now last one, we have B intersect C. Alright, so that is B intersect C is students who enjoy math and basketball, but they don't like math. Okay? Alright, so B intersect C, but not in A. So B and C is right here, not in A would be this little section right here. Alright, so this is students who enjoy math and basketball, basketball, but not film.